Hello everyone, and welcome to Furnaces North America 2020, the virtual conference. This is Dan Herring, the heat treat doctor, president of the Herring Group. The Herring Group was established in 1995 to provide professional support services to the thermal processing industry, specifically in the areas of heat treating, brazing, sintering, and metallurgy. The topic today is additive manufacturing, and in particular, a rather challenging question. Will additive manufacturing add or take away from our heat treating capacity? Let's begin. Well, no one wants to talk about their age. Let's just say the heat treat doctor was a teenager in the wacky, wild, and wonderful 1960s. And one of the icons of that era was the singer-songwriter Bob Dylan, considered by most, if not all, a rebel in his time. He wrote an iconic song, "The Times They Are A-Changin'," and that song was more focused on the older generation of his time. However, I believe it's highly apropos to today's manufacturing world. Whether change is here or change is coming, we have to accept that change is part of life. And additive manufacturing represents a change from the conventional way component parts are manufactured. Let's learn more. We begin by asking ourselves, just what is additive manufacturing? Additive manufacturing is a technology used to create a component part in which a raw material is somehow added layer upon layer to itself in order to create the physical component. Additive manufacturing is the opposite of conventional manufacturing, which the additive manufacturing world has coined subtractive manufacturing, which creates a part by removing material from a raw material form, such as bar stock or plate. The key question we must ask ourselves as an industry is, are we on the cusp of another industrial revolution? Namely, the decentralization of manufacturing. This is what the additive manufacturing technology world would have us believe. The decentralization of manufacturing perhaps began with the creation of manufacturing cells, or dividing the manufacturing process up into discrete segments. Part of this attempt at decentralization was the integration of heat treating into the manufacturing cell. But additive manufacturing technology offers an opportunity to go far beyond this by creating a discrete workplace in which a component part is manufactured and heat treated. Thus, it represents a threat to the heat treat industry. The answer to the question, are we on the cusp of another industrial revolution, appears to lie somewhere in between the total adaptation of additive manufacturing technology or the restriction of this technology to niche industries. If the technology falls short or appeals to only those niche industries, perhaps as much as 10% of the conventional machining industry will be affected. If, on the other hand, the technology is wildly successful, it will be seen as a replacement for a significant number of component parts, perhaps as many as 40%. So, the real answer is that the heat treater can expect to see a decrease in the number of machine parts that he's processing. Ultimately, perhaps, as much as a quarter of the industry will be affected by this new technology. You may be asking yourself, as I do, what is the market for an additive manufactured part? Who's going to buy parts made from this technology? Well, the consumer electronics industry, automotive and motor vehicle industry, medical and dental, aerospace, industrial machinery, academia, the government and military, and a little bit of agricultural and the architectural industry will benefit from additive manufacturing technology. Of the half dozen or so additive manufacturing technologies which are available to produce component parts, only a few of them involve thermal processing, heat treating, or sintering processes. These include metal laser sintering, also known as selective laser melting, powder bed fusion, or extrusion-based metal technology being examples, jet prototyping or material jetting, an example being literally the printing of a 3D part using metal as opposed to, say, component plastic, and layered powder metallurgy, a new and emerging technology. At this point, you may be asking yourself, what heat treatment processes are used in the additive manufacturing world? Well, for laser sintering or selective laser melting technology, we find that heat treatments such as stress relief, solution annealing, or aging are used to enhance mechanical properties such as tensile strength and hardness, and also improve wear characteristics. And these heat treatments are typically carried out either in an argon atmosphere furnace or in a vacuum furnace. By contrast, jet prototyping or jet binding requires the material to be debound and sintered. These processes are not often done in a commercial heat treatment shop, although they certainly can be. So, where does this leave the heat treater? Well, it really depends on which type of additive manufacturing technology is being used and how popular that technology will be in various industries. Let's take, for example, laser sintering or selective laser melting. It seems as if the aerospace industry and the medical industry is particularly interested in this technology, which will require the customer to either purchase their own heat treat equipment, which is possible but perhaps unlikely, or outsource. So as a result, this offers a unique opportunity for the commercial heat treater to take advantage of these types of component parts. Of course, if you're planning to do so, your shop needs to be NADCAP accredited and, as quickly as possible, develop skill in dealing with the aerospace, and medical markets. By contrast, jet binding technology will focus on selling customers a complete, self-contained manufacturing cell consisting of software, 3D printers, the binding technology, sintering technology, and the post-process tooling for quality checks. This creates a bit of a dilemma, but also an opportunity for heat treaters. In particular, should we become parts producers? Should we purchase this technology, set up manufacturing cells, and produce parts for our customers? The technology goes from the design phase to the component manufacturing phase almost seamlessly. But this means we have to invest and understand the binding technology and sintering, which we are very capable of an industry in doing. There are many technological advantages of additive manufacturing. And while I won't read this list per se, I think it's important for the listener to understand some of the advantages over, let's say, conventional machining. First of all, one of the niches is certainly small runs of complex parts. They can be produced quickly and at low cost. Also, the parts can be lighter weight than traditionally thought of. Honeycomb designs are possible, reducing weight while maintaining or even increasing strength requirements. Another advantage of additive manufacturing is the ability to make changes on the fly, something that is not common in conventional machining. And highly complex parts can easily be produced. Finally, additive manufacturing generates little or no waste, which is also highly beneficial to the manufacturer. As we come to an end of this discussion about additive manufacturing technology and its impact on the commercial heat treat industry, I couldn't help thinking of a quote by Franklin Roosevelt back during his first inauguration, just in the middle of, or at the end of, the Great Depression. As he said, "So first of all, let me assert my firm belief that the only thing we have to fear is fear itself. Nameless, unreasoning, unjustified terror which paralyzes." A rather ironic quote coming from a polio victim. However, these words might summarize the feelings of many commercial heat treaters. Do we have something to fear about additive manufacturing technology? My answer is a definitive no. It's another technology that we need to embrace. We need to understand, and we need to understand the needs of our customers so we can service them. Commercial heat treaters are a resilient lot. We can adapt to anything. And the move toward additive manufacturing, while exciting, while unknown as to its total impact, is something that the heat treat industry need not fear. For those of you who want to learn more, I've included a few simple references. These documents have references themselves to even more literature that you might find interesting or important. Notice in this presentation that we really have not defined in depth the various additive manufacturing technologies, simply because that wasn't our mission. So references in this case will be invaluable for the listener to learn more. And as always, if there are any questions, please don't hesitate to contact me. Thank you for listening, and have a wonderful conference.